In this lecture, we are going to discuss the next problem on weighted residual method. So the problem is the governing equation for a fully developed steady state laminar flow of a Newtonian viscous fluid on an inclined flat surface is given by mu d square v divided by dx square plus rho g cos theta is equal to 0. So this is our governing differential equation. Okay, so here mu is the coefficient of viscosity and v is the fluid velocity, rho is density, g is acceleration, and theta is the angle between inclined surface and its vertical. So two boundary conditions are given. So the first boundary condition is dv by dx at x is equal to 0 is equal to 0. So write the boundary condition number 1 is dv by dx is equal to 0 at x is equal to 0. The second boundary condition is v is equal to 0 at x is equal to L. Okay, so these are all the two boundary conditions and the governing differential equation is given. So the problem is like the previous problem, we have to assume a trial solution, and in that trial solution we have to substitute the boundary condition. So you can remember the three steps. First step is calculation of trial solution. So assume a trial solution, substitute the boundary condition and find the final trial solution. Then second step is after calculating the trial solution, substitute it on the governing differential equation so that you will get the residual. And the third point is after calculating the residual, you can use any one of the weighted residual method to find the final solution. So in the previous problem I have used r is equal to 0 since the specific weighted residual method is not given. So here also the weighted residual method type is not given. So here also I am going to use the point collocation method, that is r is equal to 0. Okay, so this is going to be my procedure. So I'll start with the first one, that is assumption of trial solution. We know that to select a trial solution we must look into the maximum order of the governing differential equation. So here in our governing differential equation we have square term. So I can assume that v is equal to c naught plus c1x plus c2x square, because here in the equation you have square term, so you have to assume a trial solution of minimum of x square. Okay, so this is my assumed trial solution, that is equation number 1. Okay, fine. So now first step I am going to substitute the boundary condition 1, that is substitute boundary condition 1 in equation number 1. Okay, so to substitute the boundary condition 1, that is dv by dx is equal to 0, first I must calculate the value of dv by dx. Okay, so dv by dx is equal to c1 plus 2c2x. So this is the single differentiation of equation number 1. So now I can substitute it, that is dv by dx is equal to 0 at x is equal to 0, that is c1 plus 2c2 into 0. So here my c1 is equal to 0. So substitute c1 is equal to 0 in equation number 1. So now my first equation is v is equal to c naught plus c1 is 0, so c2 x square. Okay, now the second boundary condition, so that is boundary condition 2 in equation number, consider this as equation number 2, substitute the second boundary condition in equation number 2, and the second boundary condition is x is equal to L at u is equal to 0. I mean u is equal to 0 at x is equal to L. So we can substitute it. It is not u, it is v. Okay, v, fine. So v is 0, that is c naught plus c2 L square. Okay, so this is my second equation, and I have substituted the value of x in the second equation. So now I can solve this, that is c naught is equal to minus c2 L square. So this is the second constant value, and I am going to substitute this in the second equation. So substitute c naught in equation number 2. So that is v is equal to minus c2 L square plus c2 x square. Okay, so I can simplify this, that is v is equal to c2 minus L square plus x square. Okay, so this is my final trial solution. Okay, so it's very important, this is my final trial solution. So after this we have to use only the third equation, we should not use the previous two equations. Fine. So the second step is calculation of residual. So the second step is calculation of residual. So calculation of residual means we have to substitute the calculated trial solution in the governing differential equation. So in our problem, the governing differential equation is mu d square v divided by dx square plus rho g cos theta is equal to 0. So this is our given governing differential equation. So now I have to substitute the value of v in this equation. So first I'll calculate dv by dx. So use this v here. Okay, so dv by dx is equal to c2 0 plus 2x. Further, d square v by dx square is equal to c2 into 2, that is equal to 2c2. Okay, now you can substitute this d square v by dx square in our governing differential equation. So that is mu is equal to, mu into 2c2 plus rho g cos theta. This is going to be my residual r. Okay, so that is very important. I have substituted the value of d square v by dx square in the governing differential equation. So this is my residual. Okay. Now I can go to the third step, that is calculation of solution by using any one of the weighted residual method. So I can use the first method, that is point collocation method. R is equal to 0, and I can substitute it, that is mu into 2c2 plus rho g cos theta is equal to 0. So this is my point collocation method. Remember that according to point collocation method, the r is equal to 0. So here we have used the point collocation method. So from this I have to calculate the second c value, that is c2. So that is mu 2c2 is equal to rho g cos theta. Further, c2 is equal to, it is minus rho g cos theta. Further, c2 is equal to minus rho g cos theta divided by 2 mu. So this is my c2. So while substituting the first boundary condition, I have calculated c1. Then after substituting the second boundary condition, I have calculated c0. Now by using the point collocation method, I have calculated the c2 value. Now I can substitute this in my trial solution. So remember that the equation 3 is our trial solution. Okay, so don't confuse it. So the third equation is going to be my trial solution. So this is my trial solution, and I am going to substitute the value of c2 in this equation. So that is P is equal to, so that is substitute C2 in equation number 3. That is V is equal to minus rho g cos theta divided by 2 mu into minus L square plus x square. So this is my final solution. So remember that in the final solution you should not have any constant values. So here there is no constant, but if you look into the trial solution equation 3, then you will have C2 value. Okay, so in your final solution there will be no constants. Okay, fine. So remember that three steps are important. The first step is calculation of trial solution, and yeah, so here I have assumed a trial solution, and in that trial solution I have substituted the two boundary conditions and I have calculated the final trial solution. Then after calculating the final trial solution, substitute the trial solution in the governing differential equation and find the residual. Then after finding residual, use any one of the weighted residual method to find the final constant. So here I have used point collocation method, that is R is equal to 0, and I have calculated the final C2 value, and after calculating the C2 value, substitute it in the previous equation, that is equation number 3. Okay, so in short, so we have to substitute the boundary conditions and we have to uh, calculate the constants, and after calculating the constant, substitute it in the previous equation, then calculate constant 2, substitute it in the previous equation, then finally calculate the third constant C2 and substitute in the previous trial solution, so that finally you will get the final equation.